Okay, this is fun. Hi, everybody. Thanks for coming to this summit. Ali, should we kick it off with telling some stories about Databricks, early days, or Berkeley?
Or even Berkeley earlier.
Yeah.
Whatever.
UK. Okay, so you and I go back to 2009, 2010, 2009. You got to Berkeley, and there was an email going out. I think it started with Jan or Scott Schenker sending this email to the Mesos group that's like, here's this visitor. He's going to be joining the team. And Matei and Ben and I were like, oh, who's this Ali guy? And we were very insecure and who was going to be first author still. So we were like, and then he comes in and he's jacked. And we're like, oh, okay. I hope we don't have to arm wrestle for this first author. So that was some of my formative memories of you being injected into our research project. And then you went on to like do dominant resource fairness, DRF paper, and just become like a mentor and then basically one of my co-advisors. So that's what I remember.
Yeah.
What do you remember?
Yeah, I remember a lot of fun stories. It was amazing years. 2009, 10, 11, 12 was kind of, UC Berkeley was at the frontier of all these new algorithms for the new computer. The new computer was the data center. And we were doing all this amazing research. And I remember there was a lot of skepticism around, AI, machine learning at the time we called it, and data centers and all of that. So yeah, it was best years for me, most formative years. My favorite memory is probably when we had started Databricks. And actually, there was this big debate. Should we run the company out of Berkeley or should we run it out of San Francisco? And like half of the founders wanted to move the company to San Francisco, and half of us wanted to keep it here in Berkeley. And I remember we brought in do you remember this?
I do, yeah. I think I was on the Berkeley side.
Yes, I was on the Berkeley side too. And then you, I think, called the mayor of Berkeley.
Yeah, first I think we met with the chancellor.
Yes.
And then he said, you should talk to the mayor, and he introduced us. And so we hooked up with the mayor and brought him into our office, which was not a very nice office, because Berkeley doesn't have great office space.
And he brought a lot of people with him. I think it was like, us as a researcher, I was like, oh, these are all politicians. And they came in and they sat there and we pitched them on algorithms, advanced algorithms for scheduling. And I think the mayor just fell asleep and just dozed out through the whole talk. And then woke up at the end and came up to me and shook our hands.
I think, yeah.
Yeah, and then he said, I hope that one day I will have a data brick in every home. Still hasn't happened.
It hasn't happened. I mean, maybe NVIDIA's most recent rack,
exactly.
Could be where we go someday. So those days when we were here at Berkeley, they were the most formative for me too, and there was something magic happening in the air or the water. What do you think it was, and do you think that it's still here? Has it changed since then?
Yeah, I mean, I live in Berkeley still. Yeah, I think actually the city is special, and I think the university is special. Actually, before I came to Berkeley, I did a bunch of postdocs. I actually lived like more or less in 9 different countries and visited 9 universities and lived like in different places of the world. And I think Berkeley and UC Berkeley specifically is very special. And the thing that's special about UC Berkeley is that there's this kind of attitude that you can change anything, you can question anything. I mean, academia has that in general, but UC Berkeley especially has that. And I think it was kind of a little bit of a culture shock for me when I came to the research group. Because the kind of things we were working on, I was like, that's not research. We're not supposed to do that. And we're like, no, we're doing it. It's cool. It will have impact. And I was like, well, that doesn't make any sense. This is like you're cheating here or something. It's like, no, we can do anything. Like, this is like, we're just here to change the world. So I think that's the kind of spirit of Berkeley. And I think that's, university has it, but the city has it, and its history, and, and I think that's what makes it special. And sometimes it goes a little bit extreme. Like, I think, but there's, research that has super high impact, and then there's some research that, is further out. Like, I remember there was like research on delay-tolerant networks. And it was like, oh, but, obviously the internet is broken if we want to do interplanetary communication. And we have to redesign a new internet for interplanetary communication, because eventually we're going to colonize all of the universe. So that was one of the research projects here in networking. So, I think it's like the aperture is really wide, and it helps people to kind of broaden that. And
yeah, I know that in the early days, we were operating systems and distributed systems research group, and we took deep inspiration from BSD. And I remember we went through a couple of naming iterations with what became Mesos in the end. And one of the contenders I put forward was the Berkeley cloud distribution, BCD, or Berkeley Cluster Distribution, named as inspired by BSD, Berkeley Systems Distribution.
BDAS, Berkeley Distribution of something.
No. There was BDAS, which Mike.
Was badass.
Yeah, badass. That was like the official nomenclature.
Yeah.
You have to pronounce it badass, the badass stack. But no, this was what I put forward for the name of Mesos. I said we should call it BCD.
Yes.
And I don't know, you guys, I guess you might not remember. Matei, I'm pretty sure Matei and Ben both said, no, like, who are we to, like, be so lofty as to name ourselves, like, only one edit distance from BSD? And I was like, well, we're gonna, like, build the more impactful operating system is who we are. So yeah, I did not win that vote. I think Mesos was pretty good. So
That's the Berkeley spirit.
Yeah.
Question the norms.
That's continued at Databricks. We most recently announced, or we announce many things every week, but Omnigent is a big open source framework trying to play at the harness, or that is putting forward a new kind of router for harnesses is how to think of one way to think of it. Also, we talk about open evals, which we can talk more about later. So how has that played forward from your perspective as the leader of Databricks for so long now, seeing that what we carried from Berkeley in terms of open innovation and that maybe sky's the limit mentality still carrying into Databricks strategy?
Yeah, I think open for us has been always super important. So we always want to open source standards, open source interfaces, because it creates communities. And those communities become very powerful. Actually, Databricks would not have existed as a company if it wasn't for the Spark ecosystem, because the Spark ecosystem just was way bigger than anything any of us would have done. So it's both good for the community, it's good for the world, but it's also a good business idea as well, as Databricks has proven out. So we just continue doing that. And we do it in things that we think are the most useful and will have the biggest impact. So a bunch of years ago, we did MLflow. And MLflow, actually, people don't know, but it's 40 million downloads still a month, every month. So billions of downloads a year. And what was that? It was like in the ML era, machine learning era. So say 10 years ago, people were obsessed by the best models, but it was just very hard for machine learning people to iterate on the different models. So they needed sort of a Git version controlled, kind of a way to be able to iterate and keep track of all the different experiments. So that was MLflow. Omnigent, which you just mentioned recently, that came from, there's just so many harnesses out there. And unlike large language models, people switch between them quickly. They're stochastic. Every time you ask them a question, they give you a different answer. And we can see it in the Databricks data because we serve all the different models. We serve actually proprietary models and open source models. So we have like data on all of that. And we see that people quickly switch between them. So when there's a new proprietary model or a new open source model, people quickly, within days, are moving to it. We've never seen anything like it. Anything else in software is sticky. You stick with it, and there's a decay, and people slowly churn and migrate, but it takes a while. You don't just instantaneously, everybody just flip-flop. With LLMs, that is the case. But what we saw with harnesses was that people are building harnesses on top of them, and the harnesses are kind of like old software in that they lock you in, and you get used to the interface and the memory and key sort of shortcuts and all of that. So we wanted to create something that lets you actually switch between these and have it be completely open. And the idea was a meta harness, so harness of harnesses. So it will work with your Cloud Code, it will work with your codecs, it will work with any actually of them, OpenCode, Pi, you name it. So that way you can get the multiplexing, you get the community, and the project has we just launched it this summer. And I think just in the first couple of weeks we had 1,000 forks on GitHub. So it's really taken off, and over hundreds of people contributed immediately within weeks. We're very excited, and I think we're going to continue putting out open source projects like this. I think open sources actually have a huge boon in the next bunch of years, thanks to vibe coding or AI, because before it was like, okay, it takes huge amount of effort for a Linus Torvalds to build a whole operating system and compete with, say, Windows. And at some point, someone has to pay his salary, so they get hired by companies and so on. But today, since the cost of writing software is going down, I actually think it's going to be much more palatable. And we're going to see many, many more open source projects out there that become standards.
I have a theory. It's not really here nor there, but it feels like we're going to get a GitHub version where instead of pull requests containing code, they're going to just contain the prompts. and then the PR reviewers will decide, will like run those prompts. And I think we're like moving towards that in things like OpenClaw and probably Spark, in that the work on the committers is now much more about deciding how much of the code was written by a human, or how deeply, like how many hours did a human spend on this pull request. I don't know, it gets me thinking about all the big the big ways that the world you and I grew up in and we started Databricks in is like fundamentally going to be different going forward. Any reflections on kind of the paradigm shifts as they play out for Databricks, or I don't know, the future of software dev and vibe coding?
Yeah, I do think we're going more and more towards, if you can specify what the program should do, and you kind of have the testing foundation and harnesses, then the implementation actually doesn't matter. The AI can figure out the fastest, the best implementation of it. And you might be rewriting it many, many times. But it really requires you to have this really sort of airtight way of specifying the code. And I think it's moving that way.
Yeah, that reminds me of evals. So we at Databricks recently announced this effort where we internally scraped a bunch of our own coding issues and tasks. We like built a data set, very large data set. How many? Over 1,000?
Yeah, it's a huge data set of, because we have about 4,000 engineers that are writing code every day, and so and the whole company, about 11,000 people, are submitting questions like data science questions. They want to know how the business is doing. They're working in the field. So we took all of that.
And that's like basically a declarative spec. Like you've declaratively put into these questions and answers, I assume.
Yeah.
That people ask the question, you have like the Databricks answer, and now you've got this specification for a thing that an agent could come and learn to answer. Like here's a bunch of questions we wish our agents could answer. That's a bespoke evaluation or benchmark to Databricks. And do you think that other enterprise or tech companies or just wider enterprise companies are doing this? And I actually have a lot of opinions about evals, so we can dive into this.
Yeah, I mean, I just think that there's so much contamination happening. So we wanted to just have this, ground truth. There's like every day there's something released. So we wanted to ask the ground truth for us. Which model should we use? And can we just use GLM 5.2? Is it going to be as good, or is it not? And so on. So that's what we kind of set out to do that. In general, the frontier labs are so obsessed with superintelligence and the march towards superintelligence that many of the things that we want to do every day are not kind of part of their evals. So they're focused on HLE, humanities last exam, and HLE has like these very complicated math questions and physics questions. But when we actually looked at very basic tasks that we wanted to do every day, they weren't actually doing so well on it. Actually, on the hardest ones, they were getting like 40% right. 20% right. And then on the average ones, maybe 40% right. And these are like basic questions. Like here is 1940s budget of United States. Just get us what was the spend on defense spending. So it needs to kind of scan the PDF and figure out how they presented things in the 40s and do that. And yeah, it's like, turns out that's really hard. Because the focus has been on physics and math, things that you can RL like that, not these mundane enterprise or business tasks. So we came up with this eval that we call Office QA, from Office the movie, TPS report. So we thought like, let's just solve that. So we were focused on that, and with that we were able to basically build an agent that could do the PDF parsing and do those kind of things and get close to 80% correctness on it. So I think evals in general and specs are going to be extremely important going forward. You've yourself launched a bunch of these things. Terminal Bench was started by Laud.
Yep, yeah, so we teamed up with a professor at Stanford, Ludwig Schmidt, whose group had done big stuff like CLIP and this data comp set of projects, which was big in evals and data. Basically, data comp that Ludwig had done before was where you fixed, instead of changing the model and then holding the data set fixed, you hold the model fixed and the agent, and you change the data set and have a leaderboard for that to see how by changing data sets can you improve the results for one fixed agent. So Ludwig was a big innovator in benchmarks and at Stanford, and I met up with him at NeurIPS, and actually that was the NeurIPS where we launched this thing called the Konwinski Prize, which was...
K-Prize.
Yeah, the K-Prize, yeah.
Get $1 million.
Yeah, get $1 million
Andy, right?
from me. I'll write you the check.
Yeah.
I tweeted it on stage at NeurIPS, this like promise that I'd write $1 million check to the first team who got 90% on a thing that we called Swebench contamination free. And that was basically, you have software engineers write their agent code on some test set, which is just, we scraped new GitHub issues. And we said, here are these issues that were from popular repos like PyTorch or Spark or something. Your agent has to fix these. Normally, agents people can train their agents on the test set if the test set's published. So you can do two things. You can keep this test set secret, or you can say that you're not going to scrape the test set until after all those tests are the submissions have been placed. So that's what we did. You basically made a cutoff date by which people had to submit their agent code, and then we scraped new GitHub issues for the 4 months after that, and then ran the evaluations on the agents that had been submitted, and the results were, I guess, around 10% success rate, which is really good for new benchmarks. And coming off of that launch, and then talking to Ludwig about his...
Isn't it crazy that like everything is 90% saturated, but like when you do a new one, it's like 10%?
Yeah, and it starts this cycle, and this is a new thing we're working on too, that we just announced a couple of weeks ago. It starts this, what I think of a very inefficient cycle of every benchmark, you mostly throw away the last benchmark and start over from scratch. And it turns out that we did Terminal Bench 1, and then 2, and then 2.1. And from 2 to 2.1, we were mostly like fixing 5 to 10 tasks that people had discovered were essentially unsolvable. But a lot of benchmarks don't even do those little minor version releases where they update the task, they update all these broken tasks. And so there was this culture of, this shadow culture. People who knew Terminal Bench 2 really well knew that like 83% was actually 100% because there were these unsolvable tasks. And you don't want that if you're a benchmark maker. You want 100 to be achievable, but just be really hard. Yeah. So we did 2.1, and that gave us this idea that, hey, benchmarks, the way we're doing them right now is really stupid. It's this like fame race and a hamster wheel where you do 2.1 and then, we did 2.1. People don't even usually do minor versions, but then you do 3, and Terminal Bench 3 would have a whole new set of tasks with almost no overlap with Terminal Bench 2. And instead, we should write benchmarks like software, which is you don't throw away the code base every time you do a new version of Spark. You like just make changes to the code base. You fix bugs, and you, in terms of benchmarks, you delete the old tasks that are saturated. Like now, everybody gets these right, so don't keep them in the benchmark anymore, and add 10 new tasks that are even harder. And so it's a much healthier thing because you're releasing your benchmarks every 2 or 3 weeks.
So it's like updating all the time.
Yeah, like software.
And it's like software. And that makes a lot of sense.
And you're fixing bugs.
Yeah. Actually, what I like about that is like there's this good Hart's law, which is whatever metric you use to evaluate something ceases to serve its purpose because it gets gamed. So this is perfect. This basically makes sure that your benchmark does, because that's actually what's happening. That's why everything is 90% everywhere.
Right, and so you can gently steer it too, because as the frontier evolves, we discover that like right now, reward hacking it's like part of the major frontier. Nobody was talking about reward hacking. Very few people were talking about reward hacking a year ago. Now a lot of people are thinking hard. New tooling's getting built around it. The agents are getting better at identifying it, and we want more tasks that are robust to reward hacking, or tasks that explicitly test for an agent's resilience to reward hacking. So we can do that in a week or two, is like come up with 3 new tasks, cut a new version of the benchmark. So Terminal Bench 3 on will be like 3.1, 3.2, 3.3 really fast, and very relatively small iterative updates. So pretty excited about that. I do believe that benchmarks are changing dramatically, and I actually believe deeply in what you said, that the agent and the harness code is going to be kind of optimized automatically more and more if you have good evals. And so that's a pretty big change from the early days like laying chain or laying graph or these other frameworks where you have humans thinking hard about a good way to architect your agent. Now instead you have your humans spending all their brain power coming up with the evaluation. How do you accurately capture like the distribution of hard things inside your company or your government, whatever you're trying to optimize, and then you unleash these optimizers, either code optimizers or prompt optimizers or model weight optimizers or all of the above, to just hill climb those evals. So those two trends together are where we're thinking about with the Harbor open source team a ton right now at Laud.
Makes a lot of sense. I'm curious, you with the Open Frontier, is an initiative that you guys are spending a lot of money basically helping open research, open science. Is that going to have a chance against these frontier closed labs that are huge salaries, and then there's like very secretive and there's no published results, versus this open frontier that you're doing?
Yeah, thanks for speaking at the meeting a month ago. We assembled about 100 of the top researchers in AI that are still doing open science, and we talked about the fate of science as we know it, and one of the observations is that many of the top minds are leaving academia to go get paid, go from their $400,000, $300,000 salaries to $10, $50, $100 million salaries, go from having a lab that gets 10 to 50 million in funding to a lab that has billions and billions, hundreds of billions in funding. And those two key things, the access to resources and the access to what is now competitive salaries, which is pretty insane for when we started Databricks even 10 years ago. Yeah. I think just insane, just in absolute terms across the planet, that people are having billion-dollar comp packages right now. Those are the reasons that I feel really worried about science as we've known it. And I believe that innovation is necessary right now to create a new institutional dynamics that augment academia and also create a proof of concept for the ways that we can give researchers enough resources to continue doing research at the frontier. So yeah, I guess explicitly to your question of can they compete head on? No, like we will never have a nonprofit where a combination of philanthropy and the US government, which is how nonprofit research gets funded, including this university we're sitting at right now, where they will be able to raise the hundreds of billions at the same level as an Anthropic or an OpenAI. But they do need to raise at least one order of magnitude, maybe between 1 and 2 orders of magnitude more than they are. And that's just a new shape of fundraising and probably a new way of having labs team up that they never really have had to in academia. So maybe thinking about like a lab of labs architecture. How do you have more collaboration somewhere between the way that academic labs currently collaborate, which is mostly via reading each other's papers and building off of ideas, and the labs that are in Meta or OpenAI and Anthropic, which are centrally run, all laser focused on one single stack and one model. So somewhere in between that is like a looser but still aligned collaboration of many labs that are doing evaluations like Harbor, or pre-training like Marin, the project at Stanford led by Percy Liang, or agentic frameworks like Graham Newbig does at CMU, or prompt optimization and context optimization like Matej Zaharia here, or Omar Khattab at Berkeley and MIT. So you have faculty at all the top labs, plus independent researchers doing nonprofits right now is blowing up, like not at the level of Anthropic, but like a 5 or 12 person team, just not even NeoLab, like actual nonprofit, not a for-profit. And if you can find a way to get to kind of herd those cats and get, first of all their faces on one slide, then I think it will, and then second of all, actually operationalize that, which is what we're working hard on doing now. Like, how often do you meet? How do you agree on artifacts? How do you get the models that Marin is producing, or collaborating with the labs who are putting open weight models like Thinking Machines or Reflections claims to be working on an open model and to be releasing one eventually soon. So how do you team up with these folks and get sort of the sum is greater than the parts in a nonprofit? That's what Open Frontier is, and there's actually like a kind of big burst of momentum and energy. We've been talking about it for like a year, and now Satya Nadella tweeted about like the need for this sort of thing, and Databricks is like showing the way for the possibility of this open ecosystem actually standing a chance, and so I'm really passionate about it.
Yeah, super excited about it.
How much time? 1 minute left? 1.5. Okay, so we should talk about undergrads, because we're sitting here at UC Berkeley. We both taught undergrads here and mentored them and brought some of them along with us to Databricks. You still pay hundreds of engineers to do software engineering to build frontier infrastructure. Is it hopeless to come to Berkeley? I gave the commencement speech here, and a lot of students are super worried, and their families came up to me afterwards and were like, we're confused. What should we do? So is there hope? Like, should everybody just be bailing on computer science?
Yeah, no, I think that, I don't know why this is happening. I think at the frontier labs in particular, there's this kind of sentiment that there's only 2 more years of work left, and then everybody's going to be out of job. And programming is going to go away. You meet more and more people that feel that way, especially in SF, I think. I don't know if that was also going on in Berkeley or not, but yeah, no, I think this is completely wrong. I think the AI transformation will actually take decades to go through. And it's just because it takes a long time to change society. Like, it took from 1880 to 1920 when the electric engine came about, and it replaced the steam engine, before you could really reap the benefits in society. And actually, it took from 1880 to 1920 before they saw any impact on GDP. And it's not like, okay, that was a physical thing, it was hard. No, electric engine already existed in the 1840s, 1850s. So it just takes a long time. Same thing with the PC revolution, it took a long time. And I'm at Databricks, and we have AI now, and we're trying to identify everything we're doing at the organization. And just see how hard it is that you have so many tasks that have been built up over the last, for us, we've only been existing for 13 years. Some organizations out there have been around 10, 50, 100 years. It takes a very, very long time to change everything you're doing. So I think that this agentic revolution will take a decade at least, if not more. And there's lots of new good ideas. Like my favorite example is internet already existed by 2000, but it took Brian at Airbnb till 2009. So it took 10 years after internet, or even longer, for him to come up with that idea and that to take off. But the internet was already there. People had houses that they could rent. There was nothing, there was no physical infrastructure needed. Just takes a long time to come up with good ideas and get them to percolate and disseminate through society. So I think that there's most of the interesting things that are going to happen haven't happened yet. There's going to be amazing companies, amazing ideas, amazing research that's going to be created in the future. You know, just as a couple ones that I always like bringing up, like I think there's going to be a healthcare company, and it's going to probably be worth trillions of dollars. And that healthcare company is going to be a healthcare company where you can, you can get a doctor that has seen billions of patients, and it can give you personalized healthcare. People would be willing to pay anything for that, right? If you could help the health of you and your loved ones. Or education. Education is like super important to people. Historically, VCs have always said, oh, there's no money to be made in education. But I actually think, if you look at the United States, elections are won and lost based on education. And people care about the education they give their kids. And this technology is transformative when it comes to education. So we're going to see innovation there as well, both by universities, maybe nonprofits, but also by companies. And you could see people want to, if that's the best way to train your kids, I think we're going to see that. So there's so many ideas. And I can't believe, like, this is the best time ever. Like, I wish I was born so that would have come out now when I'm like 20, 25 now and start working on, this is the best time if you want to transform the world. If you came out 10, 20 years ago, things were more kind of smooth. This big transformation is like the best time to be alive and be part of it. So I think computer science has, far to go, and I think we're going to see way more software being written in the future than we've seen in the past. So I'm super, super optimistic.
Yeah, I'm very parallelly optimistic. I work with PhDs still at Laud in partnership with the labs at Berkeley, Stanford, MIT, and the other top universities. And if you find the students who ship something, like they launch an open source project or tweet one of their papers or something, and they get a large response to it, they still feel that, and you talk to that student, those students are really motivated by impact, the way we were back with in the Patterson labs, thinking about BSD and the way that we could change the world. And I talked to them about why they would be saying no to these $2 or $5 or $10 million a year comp packages where they can go kind of disappear into one of the closed labs where they're going to do frontier research and shape the way that Claude works, but they won't be able to talk about it. And it's for the same reason still that those people, they get that getting to work on the problem you see as the visionary one, and a commitment to disseminating that to like the whole world is more impactful in the end, even than the proxy that this $10 million or $50 million check represents. That's also representing impact, but it's kind of a lagging indicator. So I think it's inspiring to me to see that these students still identify with the kind of core thing, which is this is the best time in the history of our species to be a person who wants to build something that people use and work at the frontier of AI.
That's a good way of putting it. Like, yes, you can make a lot of money at the frontier lab, but you'll never, ever have the chance to have as much impact also. Because this is just during this transformation, you could do things where, assumptions are changing, new ideas can flourish. This is the time to do that, so you should think about that as well.
Yeah.
Yep.
Okay, good. I think we're well out of time, so thanks for the chat. This was fun.
Likewise. Thanks, man.
Yeah.
Thank you.